Section 1.2 of Chapter 1. Do you remember in your high school biology class when the teacher explained that scientists classify living things as 8 different levels? Domain, kingdom, phylum, class, order, family, genus, and species? In order to do this, they look at characteristics such as their appearance, reproduction, and movement, to name a few. Well, data collected in a statistical study can be classified into different categories. The different categories of group data are based on the type of statistical analysis that can be performed on the data, and we'll discuss this more in Chapter 3. First, let's start with qualitative data, also known as categorical data, and these data consist of labels or descriptions of traits of the sample. Some examples are favorite foods, eye colors, or identification numbers. Our next classification is quantitative data, and these data consist of counts or measurements and therefore are numerical. Some examples are test scores, weights, numbers of paint choices at several stores. Let's look at some examples. Classify the following data as either qualitative or quantitative. Shades of red paint in a home improvement store. Let's think about it. Correct. Shades of red paint are descriptions and therefore qualify as qualitative data. Rankings of the most popular paint colors for the season. Careful, rankings are numeric, however not counts or measurements. Therefore, these are also qualitative data. Heights of doors. Correct, heights are measurements, so they are quantitative data. In this class, we will focus on quantitative data, since these are data about numeric variables. For example, how many, how much, how often, so forth, and allow us to perform the most types of statistical analysis. Quantitative data can be further classified into 2 categories. Discrete data are data that can take on only particular values and are usually counts. Some examples are number of pets in a household or prices of a particular pair of jeans at various stores. The next type is continuous data. Continuous data are data that can take on any value in a given interval and are usually measurements. Some examples include temperatures in degrees Fahrenheit of cities in Alabama, yearly amounts of snowfall over 10 years. Let's look at some examples. Determine whether the following data are continuous or discrete. Widths of doors in a home. Correct, widths are measurements, so they are continuous data. Number of 6-foot wooden boards it takes to build any given desk. Correct. These are counts, so they are discrete data. Another way that data may be classified is according to the level of measurement. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. The higher the level of measurement, the more mathematical calculations that can be performed on the data. Data at the nominal level of measurement are qualitative, consisting of labels or names. No calculations can be performed on data at the nominal level. Some examples include types of pets reported in a survey or bank account PIN numbers. Again, be careful. Yes, these are numeric, but they are not counts or measurements. They're labels. Data at the ordinal level of measurement are qualitative, however, can be arranged in a meaningful way. Ordinal, think of order. Calculations such as addition or division do not make sense with this type of data. Some examples include seat numbers on concert tickets or sizes of t-shirts. Data at the interval level of measurement are quantitative. These data can be ordered as well. Furthermore, differences between data entries are meaningful. Some examples include average temperatures in degrees Fahrenheit of cities in Alabama, or birth years of your classmates. Finally, data at the ratio level of measurement are quantitative, can be ordered with meaningful differences, and the 0 point indicates the absence of something. This is the highest level of measurement. Some examples include yearly amounts of snowfall, numbers of people per household reported on census forms. A memory booster to remember whether our data is nominal, ordinal, interval, or ratio is to ask the following. So first of all, ask yourself, is the data qualitative? If the data is qualitative, then the data can be either nominal or ordinal. And we ask ourselves, is there a natural or meaningful order to these data? If our data is quantitative, then we can be at the interval or ratio level of measurement. To distinguish between the two, we ask ourselves, is there a meaningful 0? Is there an absence of something? Let's look at some examples. Determine the level of measurement for the following data. Low temperatures in degrees Fahrenheit across the state for one evening in March. Correct. These are at the interval level of measurement since the data is quantitative, however, does not have a meaningful 0. Notice that 0 degrees Fahrenheit does not mean the absence of temperature, since we can go into the negative values in degrees Fahrenheit. Jersey numbers of players on a lacrosse team. Correct. These are at the nominal level of measurement. Since the data is qualitative, remember that even though these are numeric, they're labelings. The number identifies the player. So the data is qualitative and there's no meaningful order. Careful, because again, these are numeric and we could order the numbers, but does it have any meaning? Does player 2 come before player 6? Numerically, yes, but as a labeling, this doesn't make sense. So we have to be a little careful on numeric qualitative data, okay? Another example, number of students enrolled in each section of Math 147 at UNA. Correct. These are at the ratio level of measurement. Since the data is quantitative, it's a count, right? The number of students, and there is a true 0, right? There's an absence of students. 0 means no students are enrolled. Finally, positions in line at the checkout counter of a grocery store. Correct. These are at the ordinal level of measurement, since the data is qualitative and there is a meaningful order. Again, positions in line are numeric, but this is one of those where it's just a label. I am first in line, right? It's just labeling that I am the first customer, okay? But there is a meaningful order because first comes before the second person in line, which comes before the third person in line. So we can create a meaningful or natural ordering with these data.